Hey everybody, here is the second part of the video where we're doing graphical FRQs where a function is defined as an integral or an antiderivative of another function. Now we just did one problem here, and in this problem, they gave you a function which was a derivative of another function. So here they actually said, hey, g is the integral of f, and they wrote it like this. Sometimes you're going to have problems like this one, and this is another great problem that we're going to do. This one, they don't really have any notation with like an integral symbol, but what they do instead is they say, the function g not shown is the antiderivative of f. So then you have to know, okay, g, our mystery function, is the antiderivative of f, like that. Okay, so let's see what's happening here. We have f is continuous. We have a closed interval. So I might be doing the extrema test here. F has 3 implied segments and a semicircle. So that's important to know. And this is f shown above. So g is the antiderivative of f, and they give us 1 point on the mystery function g. So at 1, right here, g of 1 is 4. So you can think about g as like the amount of the corn. I keep going back to that corn problem because that's easiest for me to think about what's happening here. And this is your rate function, the rate of change of the corn in the silo, something like that. So if g is the integral of f, let's do the derivative of each side. That means g prime is, deriv of an integral cancel, is f. So f is the derivative of g, is another way of saying g is the antiderivative of f. So f is the derivative of g means that f is the derivative function. And I have to say this to myself like at least 4 times, like fully cement it in my mind so I'm thinking about it in the right way. If you don't think about it the right way, then unfortunately your whole problem will be answered incorrectly. So just saying this right here will often earn you a point on the exam, making that connection to what is given and how it relates to the information they tell you about g. Because everything that is asked in this question is about g. We want points of inflections of g. We want the minimum value of g. And, oh, there's another part on the next slide, which is here, where we're actually going to have another function, h. Okay, anyway, let's answer this question. I'm going to go through this one a little bit quicker because we just did a problem like this. You'll notice a lot of similarities once you get the hang of these. Okay, I want the x coordinate of a point of inflection of the graph of g. Now, I'm not looking at g. I have no idea what g looks like. I'm looking at the derivative of g, which is f. Okay, so what's a point of inflection again? A point of inflection is when the second derivative of g is 0 or dne, and the second derivative has to change sign. Okay, but I don't know what g looks like, so can I get g double prime in terms of f? Well, okay, if I know that g prime is f, let's do another derivative. That would mean the second derivative g would be the first derivative of f. So what I really can say here, instead of g double prime, I'm going to say f prime. So f prime is 0 or dne and changes sign. All right, so let's look at f prime. Now, f prime would be the derivative of f, or the slope of f. So is the slope or the derivative of this graph ever 0 or dne? Okay, moving along here. Here my slope is negative. Oh, right here I have a sharp point. You can't have a tangent line there. So right here, 0. Okay, moving along here, my slope is positive. Oh, another sharp point, 1. Okay, my slope is negative. Oh, wow, look, my slope goes from negative to positive. Right here, the slope is 0. Since they tell you that this is a semicircle, that means that the low point is at 3 right here. Okay, so 3, I have a slope of 0. And moving along. Is that it? Oh, right here. It kind of looks like I have another sharp point right there at 5. Now let's see. F prime has to change sign. So the slope went from negative to positive at 0. Check. At 1, the slope went from positive to negative. At 3, the slopes went from negative to positive. At 5, the slopes went from positive to positive. So you are not a contender there anymore. So F prime is 0 or dne and change a sign. And that should do it. Now, the fact that f prime changes sign, I said this in the last video, we really should relate it back to f. And I would just add on because f goes from increasing to decreasing or decreasing to increasing. Always related to what they give you. They give you F, so you're doing this whole connection here. Talk about F in the end. Okay, that's the safest way to ensure that you get the points that you earn. Okay, we want the minimum value of G on the closed interval. So minimum, they don't say relative, so we can assume absolute. And absolute minimum, we're going to use the extrema test. All right, how do we do the extrema test again? Well, we find the critical values of the function we're interested in. So we're interested in G, so that would be when the derivatives of G is 0 or D and E. And we're going to do a table, left point, right point, critical numbers. So where is G prime equal to 0 or D and E? Well, what's G prime again? G prime is F. So I'm really looking for where F is 0 or D and E. Okay, where is that? This is a graph of F. So where does this graph itself equal 0 or D and E? 1 sec. Okay, so obviously at my left point, here at 1, my graph itself is 0. And at 5, my graph is 0, and I have to include my endpoint 7. So what is that again? Negative 4, 1, 5, and 7. So negative 4, 1, 5, and 7. So left point, critical number, right point. So get this table down. And for the extrema test, we plug back into the original, which means we're going to plug back into G. Hold on, though. They don't give me an equation or anything for G. Remember here, there was something to actually plug into. There's nothing to plug into. So this is a great problem here. Instead of giving you something to plug into, they give you a starting value, which they didn't give you in this problem. There was no starting value in this question. So this means we're going to have to use the fundamental theorem of calculus. Okay, G of 1 is 4. So all I know right now is that my mystery function at 1 has a value of 4. So like at 1 second, there's 4 cubic liters of corn or something like that. So how many cubic liters of corn would there be at 5 seconds right here? So in order to do that, we're going to do the fundamental theorem of calculus. And let's just write that down so we know what on earth is going on here. The fundamental theorem of calculus says the integral of f prime of x is the antiderivative at the endpoint subtracted. Okay, so I'm kind of doing an accumulation problem because I want a final amount, f of b. So I'm going to add f of a to each side, which would be the initial amount plus the integral of the rate of change. And let's personalize this even more. Instead of f and f prime, who is the derivative again? F is the derivative and g is the original. So the final amount is equal to the initial amount plus the integral of the rate, and the rate here is f. Okay, cool. So we are going to plug into this. This is the key to this problem. So if I want to know what the final amount of G at 5 is, let's take this starting amount of G at 1, which we know, and let's add on everything that accumulated from 1 to 5. And the way that you're going to get the integral from 1 to 5 is with the graph. An integral is the area under a curve from 1 to 5. And we know that the area here is half of a circle or a semicircle, and the radius is 2. So that means I'm going to take my starting amount, which is 4, plus the integral from 1 to 5. Well, that's a negative amount, right? Because it was below the x-axis. So negative 1/2 pi r squared, and my radius was 2. So this turns into 4 minus 1/2 pi times 4. So that would be 4 minus 2 pi. All right. So at 5 seconds, right there, my amount is 4 minus 2 pi. Cool. I'm purposely avoiding negative 4. We'll get there. G of 7. Now watch really carefully. because in order to get g of 7, you can start with the original. Why do I keep putting the equals in there? We can start with the original and add on everything that accumulated from 1 to 7. Or we already know where we left off at 5 here. So we can take where we left off. Oops. So g of 7 would be where I left off at 5 plus everything that accumulates from 5 to 7. You'll get the same thing either way. It doesn't really matter. Okay, so let's go ahead and do that. I'm going to go ahead and do this one. Like I said, it really doesn't matter which one you do, but I'm going to do this one right here. Okay, so I'm going to take g of 1. I started with 4. And I'm going to add on everything that accumulated from 1 to 7. So area under the curve from 1 to 7. All right, I already know that the area right here in green was this. -1/2 pi times 4. And then I need to do the area from 5 to 7. That would be 1/2 base times height. The base is 2, the height is 2. So 1/2 2 times 2. Okay, plus 1/2 2 times 2. I hope you're organizing this a little bit better than I am. So I have 4 minus 2 pi plus 2, which would be 6 minus 2 pi. Okay, so right here, I'm at 6 minus 2 pi. At 7 seconds, 6 minus 2 pi. All right, so we only have one more to do. I need to go backwards in time to -4 seconds and see where I ended up. Okay, there's two ways to think about this. I can do g of -4 is g of 1 plus the integral from 1 to -4 of f of x dx. And when I do an integral geometrically, remember, I have to have my smaller value at the bottom and the larger value at the top. So I'm going to do g of 1 minus flip the limits of integration. Okay, g of 1 is 4 minus, okay, I need the area from -4 to 1. Okay, that would be like this right here. And that would be 1/2 base times height. The base is 1, 2, 3, 4, 5. The height is 2. And this is a negative area itself. So I have 4 minus -1/2 base times height, which is 4 minus a -5. So that's 9. So back here, what I started with was 9. Another way to do this one here is I could have taken this. No, actually, I could have taken this. And going backwards to -4, -4 and 1. In that case, you don't have your final amount, you have your initial amount. So I could solve for g of a by subtracting the integral from each side. So I would have taken g of b, my final amount, and taken away, because I'm subtracting the integral of the rate or the net change. So your initial amount is your final amount. Take away everything that accumulated. Think about that carefully. But you know what? I ended up with the same thing anyway, because by flipping the limits of my integration, that turned into a negative. So like I have the same exact thing. Okay, does this make sense? Think about corn. At -4 seconds, I have 9 cubic liters of corn. Then I have a negative rate, because remember, f is the derivative, and then I have a negative rate. So you should be losing corn, and yep, you do lose corn, because after these 5 seconds, you only have 4 cubic liters of corn. Then I have even more negative rate, a loss, a loss, a loss, a loss. Then I have 4 minus 2 pi cubic liters. Well, what is that even? Pi is like 3. So that's kind of like 4 minus 2 times 3. 4 minus 6 is -2. So yeah, that makes sense. Then I have a positive rate right there. So I should be adding corn. And does that make sense? Pi is like 3. So that's like 6 minus 2 times 3, 0. Okay, so I do go up to 0. So again, your number should always make sense. Okay, last one that I want to do with you, and then we'll call it quits. Right here, the function h. Now this one's interesting because we're talking about the function f, which is g prime, right? Because g is the antiderivative of f, so g prime would be f. Okay, then we have another function h, which is also defined in terms of f. Like here, g is just the integral of f. H is the integral of f from 1 to 2x, but it's 3x minus that. So all they want is h prime of -1 and h double prime of -1. And I actually am going to need some chain rule here. Okay, so I would recommend you do h prime of x first. And this is really good review of FTC part 2, which is the derivative of an integral. What's the derivative of h? The derivative of 3x is 3 minus derivative of an integral cancel. You plug your variable limit of integration in. Chain rule times the derivative of your limit of integration. I would plug 1 in, but the derivative of 1 is 0, so forget about that. So this is 3 minus 2 times f of 2x. Isn't that cool? So h prime of -1 would be 3 minus 2 f of 2 times -1. So -2. Okay, 3 minus 2 times f of -2. Well, here's -2. Whoops. And the function value there, let's just make sure I start here at -4, 0, and I go down to 0, -2. That's a rise of -2 and a run of 4, -2 fourths, a slope of -1/2, right? Down 1 over 2. So if I start with the height of 0, down 1 over, I am definitely at -1 there. So the function value is -1. So I have 3 minus 2 times -1 will be 3 plus 2, which is 5. Okay, next one. I need h double prime of -1. So let's do h double prime of x. So that means I need the derivative of h prime, which was this. Okay, the derivative of 3 is 0. Minus, oh my, what the heck? That's just annoying. I don't know what's happening. Dear God. Whatever. Okay, so I have 0 minus 2, and then I have to do the derivative of f, so that'd be f prime of 2x, chain rule, times 2. Okay, let's simplify that a little bit. We're almost there. So I have -4 f prime of 2x. Okay, so h double prime of -1 would be -4. F prime of 2 times -1 is -2. -4 times, all right, now I need f prime at -2. So go on the graph of f. F prime would be the slope at -2. Well, what's the slope here? I already said it was down 2 over 4, which is down 1 over 2. Slope of -1/2 times -1/2. -4 times -1/2 is 2. Cool. So here is one for you to try. I'm just going to pause this here. I'd recommend that you pause and actually give this one a try. I'm going to scroll down and give you the answers to check just so you can get some feedback. This is another great problem where we have a function defined to be an integral of another function. So like here is your derivative, and you're answering all kinds of questions about G. I love part C. Part D is actually really good. They're all good. All right, so hopefully you have paused by now and you've tried this one. I'm going to scroll down and show you the answers just so you can get feedback, okay? So I'm assuming you've tried the problem when you're looking at the answers. Pause if needed. You're definitely going to need to pause to actually check. The last thing I just want to show you is here. This was one of your homework problems. I gave you 2 problems to try. I just wanted to give you, oops, what am I saying? Not that. This, oh my God. Okay. It was the FRQ from 2012. I'm going to grade this and give this back to you, but these were the answers. So you might want to pause and just like look and see, do these look familiar? You just did this problem and gave it to me. So hopefully these answers look familiar to you. Okay, cool. That's all. That's enough for this topic. We're going to practice more in class, and I hope you have a wonderful rest of your day. Hi, Owen.